and that chapter is called torsion, right? And this is, to be precise, second chapter of your fifth unit, right? So we already covered stresses, and after stresses we will start torsion. Okay. Just about introduction of this chapter, as we can see over here also, that circular shafts which are whether it is a solid or hollow, and these are used to transmit power, right? And while transferring power, these shafts are subjected to torsion, bending and end thrust, right? And in this chapter we'll study the case when shaft is under pure torsion only. We'll not study that if it is under torsion, bending and end thrust. We'll study when the shaft is under pure torsion only, and in that particular case the shafts will not be associated with bending moment or axial force, right? Okay, so to explain this concept, that how actually one shaft is under the application of torsion, bending and end thrust, I try to made one diagram. This is the okay, this is the diagram of an maybe a gearbox, and this input is coming from this side, from the engine side, and there is the output is going towards the after the gearbox, right? In this, these are the different gears, and this is the main input shaft of the drivetrain, and this is the output shaft of the drivetrain. Now this is the main shaft, and this main shaft is under the application of end thrust, because this shaft was fixed already under the some bearings, so it was under the application of end thrust. End thrust means it was fixed under the application of let's say tensile or compressive force. Okay, and because of these are the different types of gears which are associated with it, and in these gears there has to be certain weight of these gears, and because of the weight of the gears, this complete shaft was under the application of bending moment also, and because this shaft is under rotation, so this shaft was under the application of torque also, because it is only twisting is only there, because whenever we provide to rotate something, we have to apply torque to it, so twisting takes place, right? So there are, in this case, there are three different points, three different aspects which this shaft is undergoing. One is the torsion because of transmission, one is the end thrust because of this shaft is fixed between two points, and another is the bending moment because of the because of these four different gears, and because of the weight of the shaft, right? Okay, so but in this chapter we'll consider only the pure torsion, that is the shaft is under the application of only torsion. Okay, now if you can see that this is the shaft and this is the shaft, it is fixed from one end, but on the other side if we apply torque to it, on the other side by red colored drawing I try to draw that I am applying torque to it. So in this case the entire shaft is twisted. It is like from one end it is fixed, but from other end it is I am applying torque to it. Okay, so there are certain assumptions that we have to follow if we are doing the analysis for pure torsion. And what are those assumptions? These are 5-6 assumptions, but it is very easy and one can understand all these assumptions, but one is very important, and that is the plane cross section of a circular shaft remain plane and circular before and after twisting, right? let us explain this, how it actually works. In this, if this is the shaft, which is under the pure torsion, and these are the different planes. This is one plane, another plane, third plane, fourth plane, fifth plane. Likewise, these are the different planes. And if I draw the side view, I am seeing the side view of this and this side view. Likewise, every plane can be drawn in a side view, and this type of side view it will be there. Now if we can see that this plane will be plane only. Plane only means this will be only a circle only. This will not change into ellipse or like that position. So that's what that this assumption was saying, that plane cross section of a circular shaft remain plane and circular before and after twisting, even before twisting also and after twisting also. And the same wording is already told by all diameters of the cross section of the shaft remain straight with their length unchanged before and after twist. He told you the same expression in two different languages. Likewise, in the fifth point, what one tries to explain is that all diameter will remain same. That means the circle will be in the shape of circle only, even before and after twisting. It will remain same, right? Okay. So these are the different assumptions. Now we have to derive the torsion equation, right? And that torsion equation is T by J is equal to tau by R is equal to G theta by L, and we'll extensively use this torsion equation. Okay, let us see this is the case for it. Okay, in this case what happens is, this is the shaft, and in this shaft if we draw one line AB, and this is the side view of the shaft, and this AB line is B point is this marked on the front view, right? Okay, and if this shaft is under the pure torsion like T on this side, like T on this side, if we do so, then this B point will shift to point C. This B point will shift to point C, but on this side it will remain same. Okay, but on the side view it will go like this, like this arrow is indicating, it will go like this. So B to C it will there, and in this case if we see the side view, it is this theta angle, right? And theta angle is called as angle of twist, whereas this is called as shear strain, and this shear strain is gamma. This shear strain is gamma. Okay, now if we try to calculate the value of BC from this diagram and as well